Hello, everyone, and thank you for joining us today for our session on ethical AI. We'll jump right in and introduce ourselves. I am Shirley Zelser. I am the Global Head of Analytics at Merkle, and I'm very thankful to have Ben joining me today. Ben Royce, do you want to go ahead and introduce yourself?
Yeah. Hi, everyone. I'm Ben Royce. I'm business development for cloud AI services for Google. Basically, I work on all sorts of AI-related use cases for Google Cloud customers.
So, we're going to talk about AI and ethical AI, but before we really dive into all of that, let's talk a little bit about AI in general. AI is not really a new concept, it's actually been around for decades. It started out back in the 1960s with techniques that would help with cognitive functions. And, around the 90s and 2000s, we started hearing about all this stuff called machine learning and the ability to really start programming and using this machine learning to help us advance everything that we're doing. And then it started and it advanced into deep learning, which is a lot of the work that we do today. So when we think about AI as it applies to marketing specifically, there's a lot of different tools and techniques that we use within marketing that are driven by AI and machine learning. So some of those things that we're talking about today include natural language processing and really taking both talk and text and using AI to derive learnings from that, image recognition and trying to understand and predict what's going to happen based on certain images, decisioning and next best action, probably the most common use case. So every time you think about modeling or segmentation or developing algorithms, a lot of that comes into this bucket. And then personalized customer experiences, whether it's on the website or whether it's, in every type of customer interaction. So again, we're using all of this AI in such a meaningful way, and it's really advanced what we're able to do in marketing. That being said, however, we're also starting to see that there are some pitfalls with using AI specifically in marketing, but then in other applications as well. So I think one of the best examples of this was when Amazon kind of touted that it was developing this really cool recruiting tool that was AI based and developed. And then after they started putting into use, they actually had to scrap it because they realized that it was biased against women. And they didn't actually realize that when they were developing the tool and sort of saw it only in practice. So I think that that is a really good example of where AI can be used really powerfully for really good things. But if you're not careful and you're not using it in the right way, can also lead to really unintended bias. So, what we're talking about today then is ethical AI and how to use AI in the most ethical way possible. So, what is ethical AI? So, we're thinking about it as artificial intelligence that complies with well defined ethical guidelines regarding fundamental values like individual rights, privacy, non discrimination, and non manipulation. But what does that actually mean for Merkle specifically and for Merkle Analytics more specifically? We're really focused on the ethical application of data and analytics to all of the different marketing, measurement, targeting, et cetera. But I want to be clear that we're not in the business of saying what is ethical and what is not ethical. We really are in the business of transparency and making sure that everything that we do is extremely transparent and that we can actually explain our use of AI. So, through all of these different techniques that we're going to be talking about today, we want to make sure that we understand the data going in, understand how it's being used, and understand how it's being put into market to ensure that there's no unintended bias. And so, with that, I'm going to hand it over to Ben to talk about what he's seeing in the marketplace.
Sure. So one of the top conversations that I have probably weekly at this point is if there is bias in some of this data that AI uses, why take the risk? The reason is often is the first one that people bring up is efficiency. There's a lot of efficiency gains through using artificial intelligence. That could be for on global scale. That could be for very small tasks, for example. That can be for just processing and cleaning data, things like that. The other part is that what I don't think it's mentioned enough is when you apply AI to certain problems, you discover a lot more about the data than you might not have seen otherwise. And that's actually why the bias conversation comes up a lot, is because they discover that the way they had been doing it, or maybe have been, the data in the past has found some, unfortunate results, right? And that they're discovering how these organizations and their data, this kind of pervasive problem creeps up and through AI. So you actually get a lot more insight by deploying AI. So it's not just saving time. It's usually being more accurate and having a better understanding of your organization's data. We know that organizations that apply AI tend to outperform their peers when it comes to growth, compound annual growth rate, and they tend to outperform to shareholders as well. So there is a lot of advantage to be had, but it's a new paradigm of how to think about it and make sure that you are not, one, perpetuating anything that does exist that is biased, but also preventing bias that might be accelerated because of the faster and more efficient decision making that comes through. So where does that come from? Who is ultimately sort of the driver of these? One of the big points I make with the customers that we work with is ethics in artificial intelligence is not just the responsibility of the data scientist who is, creating data sets, organizing them, structuring them, and training models. It goes all the way through the executive suite. And this is important for two reasons. One is ultimately, if we don't get ethical AI right, it will sooner or later become the responsibility of the executive in some sense. So there's some direct responsibility there. But two, there's also a lot of the insight that comes from artificial intelligence is not applicable to the daily tasks of a data scientist, but is actually very applicable to the executive suite, right? They might want to know the interesting the patterns that we discover in artificial intelligence because we now are using more clever, more advanced techniques with the data the organization has, and that means we find new insights that we might not have found with other techniques. And we'll talk a little bit about explainable AI. And I've found an interesting pattern where a number of, I'd say, very forward-thinking executives are now paying a lot more attention to the byproducts of their artificial intelligence while reaping the benefits of the intended product, right? And that might be they learn about what are the driving factors of a model. This has happened a number of times in marketing. Like one of the big problems in marketing we've always faced is we spend money somewhere and we know that some of it, we know it's working, we just don't know where the inefficiencies are. And we're getting better and better than that with data analytics. With artificial intelligence, we're finding that we can now talk and say, this is actually a major driver, but only in the context of these two other drivers. It's a much more detailed conversation that I think marketers, especially in the exec level, would want to know so they can talk to their clients about that as well. So it's not just the data scientist or the head of analytics that's responsible for ethical AI. It is often when it gets down to the CEO, the CDO, the CMO, and even in recruiting and talent management. One of the questions that we're seeing repeatedly with really talented data scientists is they're asking, what's your procedures, what's your policies around ethical AI? And some organizations are not prepared to answer that question in an interview, fluently, I would say, and that's kind of a problem in itself. So, if you get this wrong, let's talk. I always say, here's the risk first, right? One, if something goes out, just like with the example with Amazon, it's not exactly a great talking point to say, hey, by the way, we found out that we were biased against women in the hiring process, or our AI accelerated that, at the least. It's not a good look. It doesn't drive any shareholder value. It doesn't drive any performance that anyone wants. So there are brand effects and there's reputation associated with it. We do see this in, for example, trust scores with brands. We see this in interviews when data scientists come in, they ask simple questions. With this, they should you should have your explanation and remedy. The other one is that when you have lower trust with implementation, the ROI goes down. Like biased models aren't just a social concern; they typically underperform, right? And one of the things that I love about artificial intelligence is that we can apply artificial intelligence to artificial intelligence to find out what is right, what is wrong, what's working, what's not, and make adjustments pretty quickly, right? But the problem is if we don't even know what we're looking for, it reduces that return on investment. And I'll say point blank, I think every CIO and CTO out there that's implementing AI is familiar with the costs of deploying AI. That could be in getting the data arranged and organized properly. That could be around actually training the data. If you have large data sets, it takes a lot of cloud computing power to train them. The last thing you want to do is have a bad model or bad theory going into training a model and then have underperforming assets, right? And the last one is, and this is in a tight labor market, the last thing you want to do is make it harder to hire someone. The cost of acquisition of data science talent has always been high. We're actually seeing an even greater shortage in the management of data scientists, right? Because there's already a shortage, which means there's a shortage of expertise and number. So if we don't have a good policy and a good procedure around deploying AI in an ethical fashion, you will find it harder to hire talent, which is just bad for the organization long term and bad for long term knowledge gain. So one of the things that I have had conversations with the C-suite is often around making sure that you have a way where people can object, not necessarily, torpedo something, but at least have the ability to say, hey, I think there might be a problem here, or I think there might in the future be a problem there. This is something that's really preventative. And that's what they say, plans are useless, but planning is indispensable. Honestly, you'll find that some data scientists, for example, are incredibly knowledgeable about a certain type of data, right? They just have a lot of experience with it. Great. That means they're more attuned to knowing what trouble there may be down the road, right? Let them express that and at least come up with a mitigation plan, or at least a report saying, hey, we thought this was a concern, turns out it's not, or we thought this was a concern, it is, what are we going to do about it? And at least have that conversation earlier than later, because the panic based response is rarely any better than the planned mitigation, right?
And I think what's interesting here is also making sure that you factor in other industries, right? Because data scientists might be very familiar with the data that they've used in a specific, like maybe if they're in financial services, they know that data well, but they might have a lot to learn from somebody who works in retail and knows the
Yeah.
potential biases in different types of data that are in that industry.
Totally. The knowledge sharing factor in AI has so much potential, because almost every marketer is going to at some point use zip codes. They're going to be using, state level data or just general like market area data. This has implications, and you might have great experience from the lending industry when you get into marketing, which is entire. And right now in the data science community, there are a lot of people moving between industries because there is a shortage and they are interested in a certain area. They can now kind of specialize in something and choose what they want to. So absolutely. That's directly correlated with the sharing these concerns with the development teams. If the executives have a concern about something, they should have an open dialogue with the data scientists doing the model training, and the model training data scientists should have the same open. This is like a forum. Think about it. It seems to be the best method that we've seen so far, and the space is rapidly changing. Being aware of these potential problems and having them be nothing is way better than the alternative, right? And this also means that if something does go wrong, you sort of have made sure that everyone doesn't have the ability to say that I'm not responsible for that. We're all responsible for that. Executives and the data scientists and everyone in between, because that's ultimately what makes these systems work and work better than they would have without the process. Google has spent a lot of time thinking about this problem because we were typically one of the first to implement some of these, and also we spent about $5 billion on research on this sort of thing. We had to come up with some sort of framework. And I'll tell you, the technical side is hard. I actually think the implementation of a policy is actually harder. And of course, anyone with a background in public administration would probably agree with that, right? So here's some of the things that we put out publicly as guidelines and ones that we follow ourselves that might be a good start for organizations that are thinking about or tinkering with the ideas of which use cases they might want to apply AI to. So one, the standard that we have, for example, is that it should be socially beneficial. This means not being, don't just not do harm, but actually be beneficial to people. That could be for consumers, that could be as a user, but there should be some benefit to people actually using it over not using it, right? Not just a lack of harm. Avoid creating or reinforcing unfair bias. Sometimes we find out, and we didn't know, that the data we had bias baked into it, not explicitly, not intentionally, but it had over time, which means that if we automate a lot of this stuff, you're going to be automating the bias. We should be not just avoid creating it, but also reinforcing any existing bias. So that's a net positive in the AI community. Tested and built for safety means anything that involves physical harm, things like that, can be really, really dangerous in the AI space. Generally, I say it's not a good idea to automate a lot of these things. When I talk to people in the Department of Defense, they have very strict rules around this. They say, automating a prediction around whatever, how long it's going to take to deliver something is one thing. Another side of the coin is working with anything involving weapons. Being accountable to people, just because it's mathematically correct does not mean it's going to work for everyone. I think this is a problem that often the engineering mind and analytical mind can fall into, is saying, well, it's technically correct. That doesn't mean it's ethically correct or is going to actually work correctly, right? Privacy and design, this is about usually around the data collection stuff, making sure that we say that you're not overexposing users even when in a model, right? What data is being used, and would the ultimate users or the stakeholders be okay with that data being used? We're seeing this as a much bigger debate in the last few years than we've ever seen before. High standards of excellence. A lot of people are very ambitious. They want to get something out the door. They want to, hit some target. The fact is, if the model does not perform well or measure well, it is not scientifically excellent. It is not, and it hurts the entire community. But also, these models do not perform well. The only exception I might have here is that if you're in experimentation phase, let's find out if it works. That's fine. Putting it in production is another conversation, right? And basically make available for uses that accord with these principles. We should make sure that these apply generally across models that we play, whether it's a prediction, whether it's a price, a dynamic pricing scenario, whether it's audience segmentation. We should make sure that these are available for people to use if they are ultimately better than the previous solution. You can't just say what we should do. We say what we probably should not do. Cause harm in general. This is a pretty standard ethical statement, but it is true. You have to keep it in mind, and that's what prevents these disasters. No direct injury. That could be weapons. That could be, for example, this is the concern around a lot of automated anything in the physical realm. If you have kinetic energy, that could be trucks, trains, things like that. That has potential injury involved. Be very careful on how this gets used and when it gets used. You can always put limits and say we're going to use it in this scenario only, or in these pre-approved scenarios, but not fully autonomous decision making, for example. Surveillance, this is what is often the fear of a lot of people, especially in the public sector space. If we're, one of the debates that I've seen is that people talk about facial identification. There's a difference between facial identification and facial recognition, right? Recognizing it's a face seems to be okay with most people. Recognizing your face, however, seems to be more of a problem, right? And so there's an important distinction there, which is why the wording matters, right? So surveillance can be, identifying a human is in the building is really important when you work in construction. Which human it is might be okay if it's your employer and you were known that and informed that this stuff was happening. But if it's in random public spaces, that's a different story, and that's a debate for public spaces and such. But identifying humans and identifying a specific human are two different scenarios, and I think they often get blurred. And of course, don't break the law with this stuff. I think international law and human rights, there is a general sort of standard around this globally. Some countries are a little different than others, but it's important to say, if you deploy models widely on a global scale, you could probably have someone who knows the laws of the markets that you're deploying in. This even applies within the United States, specifically to certain states within the United States. They have different rules. For example, Illinois has a law around facial identification, not recognition of a face, but identification of a specific face. That it applies in the state of Illinois. That's worth knowing. So rolling out on a market or state-by-state basis is often a solution to make sure that we don't violate any law where it might be legal somewhere and not legal somewhere else. Let's be thoughtful around that.
And I want to go back one second, because I think it's important to talk about the whole overall harm and reinforcing unfair bias. So, you gave kind of an extreme example of guns and weapons and things that could be detrimental, right? But even on a much smaller scale, right? Like, let's talk about a company that might have a loyalty program and they're trying to market people about the benefits of that loyalty program and all of the benefits that a consumer would get while joining the loyalty program. If you have unintended or unplanned bias in those types of models, you're essentially giving a biased population all of these perks and benefits and
Mhm.
essentially doing harm to both the consumers and those that are not getting those invitations and to your brand, right? So there's definitely that like large kind of detrimental to society, like, people will die type of harm, but there's also the harm of just, you don't want to give people perks on a, bias in a biased fashion or things like that. So, we I think this has applications that are very large and serious, but also very small and have consequences kind of across the board.
Yeah, economic harm over the long term is pretty bad,
Right.
right? So
Right.
yeah, it doesn't. I don't just. Yeah, that's a good point. Not just going to the hospital. I mean, like it could be,
Which is harm for sure.
yeah, yeah. But getting hit in the wallet a number of times over a lifetime is, is just as harmful in a lot of ways, especially to certain communities that are vulnerable to it. One thing, and this is where I tend to be a little critical of the data science community, is that explainable AI is often a solution to two different problems. Is one, it helps us explain why a model is either predicting or classifying the way that it is, and it kind of prevents the black box problem, if you will. But the other one, and this is the critique of the community, and I'm glad we fixed it, but it was a ongoing problem, is that we fell into the trap of saying, well, we tested them. We built a model. We tested it against another set of data that we knew was accurate, and then we get an accuracy score. Maybe it's like 98% accurate. Great, that's a pretty high and pretty good accuracy. Like for example, if a natural language model understands spoken word and it gets 95% more accurate, it's at human levels of understanding. Like it can transcribe the words that are being said into the words that are on the screen. Right. That's pretty good. Right. The question is why, and why is it predicting what it is when it gets it wrong, and what are all the background around each of these predictions? So, for example, we didn't have this, I think, or at least it wasn't popular in marketing or in other AI use cases where we wanted to say, we said, hey, it's 98% accurate, but that 2% was actually a pretty critical 2% in some scenarios. We wanted to know why it got it wrong, and we kind of said, well, 98% is pretty good statistically. It's mathematically as correct as it's going to get. That's okay. And it's like, well, no, we want to understand why it, even if it is right, why it came to that prediction. That's where some of the executive insight comes from. And it's funny because a lot of people gave accusations into the AI space saying like, we don't know how it works. Well, explainable AI sort of solves a lot of this problem. It says, hey, we predicted that the cost of shipping something between two cities is X. Explainable AI will, for example, say 40% of it is because of the distance, 20% of it is because of fuel prices, and 10% of it is because of weather, right? And it's like, okay, that's much more helpful and really insightful, even if it is a really good prediction. Explainable AI also gives the benefit where you can say to executives, not just on that one prediction, but on all the predictions, what's driving and executives eat this up, right? They say like, I now know that the distance is the majority of the driving factor of the price of shipping, but it's only 40%, right? Like that's helpful to know. It's business insight that maybe a data scientist might say, yeah, nothing wrong with it. But it doesn't help me make predictions better. It's because it's explaining the predictions. This is helpful also for anyone who's implementing AI where there's a resistance to it. So, for example, I've worked with customers in scenarios where there's one person who's an absolute expert. They've been doing it for 30 years. They know it really, really well. They're industry expert. They're a function and capability expert, and they're very suspicious. I showed them an explainability report, and they go, that totally makes sense. It's also helpful for them because when they look at the explainability report, they know when to override it, right? They can say, I'm an expert. I know something. Like, for example, in the transport example, we have scenarios where, let's say there's a labor strike. Maybe our model did not include and can't predict labor strikes. They're relatively unpredictable compared to prices or the cost of fuel, for example, right? So we run into this problem where we don't have labor strikes in the model. Therefore, this expert knows there's a labor strike coming up, and they know, look at the explainable AI report and say, you don't have anything in there about a labor strike. Fine. I can now override this decision. That's a good thing and makes the organization better off in the long term. So explainable AI is something that we didn't start with in the community initially, and now we have rolled out into a lot of scenarios that has lots of benefits other than just explaining. It helps with executives. It helps understand when experts can know when to not listen to this decision engine, right? And that it makes the organization smarter, and it also brings in stakeholders to know what the limits, but also when to rely ultimately on AI-based decision making. So that it is a human component that explainable AI helps with. So back to marketing, how are these algorithms being used is one of the questions. Are you reinforcing, like, are you optimizing an audience towards something? That's probably a goal of yours. Is it optimizing it unfairly? That's a question that needs to be asked, right? Not all AI models work the same in each channel, because each channel, like, you could be working on TikTok versus YouTube and so on and so forth, right? There are different audiences and different behaviors, and that means we kind of have to adjust accordingly for each one of those channels, right? We know this because user bases over time tend to fragment, right? And that means that one is growing in one space, one is growing in another. That means that the data being used might need to be different, or
Where the demographics might be different between them,
right?
right? Like your example was perfect, right? Like the generation who uses TikTok could be very different than the generation who uses email and direct mail, or
Totally.
it can be totally different. Yeah.
Yeah. Um, I mean, I think a lot of media partners would love it if their user bases were exactly the same as the general population. They would love that, right? But it just doesn't happen naturally that way, right? It actually over time tends to split and splinter, because an active community becomes more active because it's an active community, right? And then so then it starts to literally just in a demographic sense can move things around, where, like, it could be like gender, it could be location, it could be by age, income bracket. All these things matter. Like, one of my favorite statistics was around the income demographics of people who like certain genres of movies, right? Like, the horror genre is very young, but also much lower income, right? But for some reason, like, documentaries are also quite young, but much higher income. It's like, well, if you're targeting based on content, this is important to know, and you might not want to reinforce bias when it comes to those different groups. The last one is that the decision making engines should be, like, constantly validated. So one, there's a concept called model drift in AI, where we want to make sure that we retrain models with new updated data so that it doesn't sort of atrophy. They call this model drift. Model drift can happen over years. In some cases, it can happen over days, right? If you have a rapidly changing marketplace, models can literally become less accurate over time. So you have to build a system that basically retrains them, and that means that the new data coming in has to be validated just like the old data that went into training the model in the first place, so that you don't have an unbiased model, and then later, because you retrained it a couple of times with data that did have bias in it, you made it more biased, right? And it's like the one-time report card for a model is probably not a sustainable method. It's probably frequently, that could be quarterly in some cases. I know some customers that do it on a monthly basis. Other ones do it once a year. They've talked about, for example, internal audits, just making sure, hey, we're going to take a random sampling of these outputs of these models and just make sure that there's nothing funky happening here, right? And that's really important as a system. It's also a talking point for a lot of executives. They love to tell people, by the way, it works, and we test it every month to make sure it still works. And when you work with us, you don't have to worry about this rampant bias that might be in these data sets, because we audit it ourselves. That's a good thing for the community. It's a good thing for the user base, and it's a good thing for the organizations that deploy these things.
Yeah, it's a really good thing for brands to be able to tell their consumers, right? Because if you're a brand that says, "Hey, you give me your data and I respect that, and I make sure on a constant monthly basis that I am not using it in a biased fashion," I think that's a really good,
Yeah.
powerful statement for a brand to be able to make.
It's good stewardship, right? It's at one, and yes, I know it sounds good in the marketing world. We love that, but it also is good, right? It is
Yeah,
ethical, which
totally.
is I think everyone can get on board with.
So then jumping into actually how we use this on a day-to-day basis. So when we think about the analytics workflow and all of these things that we're doing that use AI and machine learning, we've really bucketed into four different areas. One is around data prep and really how all of the data comes together, how we're making sure that we're looking at the different data um, elements and making sure that they are not only not biased, but that they're not a proxy for something that we would not necessarily want to use or is unethical. And then as we are actually building or designing a model, like making sure that we're checking for bias in the methodology and that we're continuing to update the models in the correct way, then a critically important component is actually model validation and looking at the model itself and looking at its performance as we're about to implement it and put it into market, and making sure that there's nothing that we missed or that there's no biases against the general US population that we're not expecting or that we don't want to see. And then finally, and I think Ben actually touched upon this a lot in the last slide, is when you do ongoing model scoring, you have to make sure that your model doesn't drift and get biased from the new data that's coming in. So let's dig into each one of these a little bit deeper. So on the data prep side, right, I think that a lot of industries have sort of created these lists of what they call, no use variables, right? Especially in financial services, there's a lot of variables or attributes that are a no-go and they don't include in the models, right? But what we've seen over time is that, AI is really freaking smart. And so the tools actually use other variables that you would think are pretty innocuous or harmless to proxy for some of the variables that are considered ethically unviable. So a great example of this is zip code. So, a lot of times zip code is totally fine to use. And a lot of times zip code is actually a proxy for example, ethnicity, right? And so when that becomes the situation in a model, that's a conversation to be had and saying, do we really feel comfortable using this variable or this attribute when we know that it's a proxy for a variable that we typically would not put in our model? So then, it becomes an issue of data profiling and understanding, and then also creating a risk assessment for all of these different variables to say, are they, unbiased, or are they totally safe to use?
I'll just jump in one thing on the
Yeah,
zip
yeah.
code is we've done tests on this. For example, a 5 digit or I think there's a 9 digit zip code that can be used. That is ultimately very specific, right? The 5 digit zip code, which is the most standard one, still has quite a lot of, for example, ethnic overlap and a lot of, depending on the city, depending on the state, the country, right? But as you go actually lower in specificity, so like maybe a 3 digit zip code, you can actually score and say like, oh, actually there is very little, or it's more closer to the general mix of the population. And that actually, like, you can measure that and say, hey, I'm reducing the amount of ethnicity in a given number, but also without reducing any accuracy. That's entirely possible. It happens quite a lot. Like a 3 digit zip code is often a lot safer. And this is a very easy fix in this case, right? Just drop the last 2 digits, right?
Right.
And you can reduce a lot of it without losing the
Without losing the power of prediction, right?
yeah, it's not necessarily like zip code or not necessarily. Sometimes just, take off the last digit or two, and that can often solve a lot of the problems.
Yeah, great call out. So then as we go into model design, there's a couple of things here. So one is thinking about the data that's coming in that you're actually building the model off of. So, as opposed to actually looking at the specific variables, looking at the actual sample that you're using to train the model. So a lot of times, what we've seen with our clients is that you use campaigns that went live a year or two ago, and then you look at those results, and that's what you use to then train the models going forward. But sometimes those campaigns actually had bias in them, or they had bias in their responders. So all of a sudden you're teaching your model now to be biased, essentially. So looking at those samples is critically important. And then also, once you're building the model itself, there's certain techniques and tools that you're actually able to do to make sure that your model is as least biased as possible. So one is feature engineering and really removing correlations between certain features and protected class variables. But then I think also equally important is in the methodology of building the model itself, there's ways that, without getting too technical, that you can add a fairness objective function, or essentially telling the AI or the machine learning model, hey, predict the best response possible or predict who's most likely to purchase. But while you do that, also make sure that your model is fair. And so the model then takes these two sometimes competing things and works with them together to make sure that the model that you're developing is unbiased. Then model validation. So, typically whenever we've built models, and this goes back to, times before we used any kind of machine learning, you always do validation. You always have a separate sample that you test it against to see if the performance remains the same on this like untouched sample. But what we're doing here in addition to this is to understand really if there is a biased population that you're either trying to segment or give an offer to or communicate to in a certain kind of way, is look at the selected population of that model or the top 10% of that model and compare it against the demographics of the entire US population. And that's really going to allow you to understand if there are specific segments that you may or may not be excluding and if you're okay with that. And sometimes the answer is yes, you're okay with it. If you're a women's hair care product and you bias towards women, totally fine. If you are a student loan brand and you're biasing against a certain gender, probably not so fine. So obviously, these things have a nuance depending on the brand and depending on what the brand wants to do and what they're comfortable with. But I think having that understanding of where that bias comes in your final model is really, really important. And then finally, we have model scoring. So again, I think Ben touched on this a lot, but adjusting scores over time and making sure that, if you put something into the market and it appeals to a certain demographic more so than others, because we test and learn all the time, right? So if you're putting something or a campaign into the market and it really appeals to a certain demographic, but that's not necessarily the demographic that you only want to market to, you have to make sure that as the model continuously learns from the market, that you're adjusting for this and that you're taking action against the potential drift of the model to become more biased. So again, lots of different techniques to be able to do that. So we figured it would be helpful to talk about a little bit of a case study, and I think that there's something really interesting here as well at the end. So, we worked with a potential loan client, and they were looking to build models to predict who's likely to respond to their loan offers. And so what we wanted to make sure that we did was we built a model that obviously didn't have any bias in it. And the methodology was to look at all of the variables or the attributes that we were going in and using. And what we found here that was really interesting was two things. One is we already talked about the race and ethnicity proxy. And we saw that there was a proxy based on occupation this time. So the occupation was actually a proxy for race and ethnicity. So we decided to exclude that. The other proxy that we saw that was really interesting was either interest in gambling or interest in care and beauty products was very closely proxied to gender. So, in having conversations with our clients about that, we decided, let's remove those. We don't actually want to have that type of bias in the model. Then we went through and we developed the models and, in the methodology that we talked about before. And we did all of these validations to ensure that there wasn't a bias in the population. And we actually built the model in multiple ways. One, removing all of these potentially biasing variables, and one, using them just to see what the difference in performance would be. And as Ben mentioned in the beginning, it did not detract from the performance of the model, right? Like we were actually able to achieve a very similar level of performance while excluding these variables that we thought would be potentially biasing or unethical to use. That being said, though, we have come across situations where when you take out certain variables, your model performance actually degrades a little bit. And then it's a very interesting conversation to have with the client and say, listen, ultimately it's your decision, right? It's your brand. It's what you want to put out there in the marketplace. Would you rather have a model that is slightly more predictive and better ROI? Or would you rather have a model that you can stand behind and say is very ethical and unbiased? And what I will also add to that is, generally speaking, when we use that quote unquote poor performing model, it actually exceeds expectations once it learns from the marketplace within a couple of months. And the reason for that is typically that the models themselves have learned from biased data in the past, and that's why they perform slightly better when you just look at it in a bubble. But then when you actually put the unbiased model into the marketplace, you're actually potentially tapping into new communities or new populations that you haven't talked to in the past because of these biases that you've had in the past. And so you discover new responders or new clients or new customers, and then your model constantly learns from that and becomes more and more better performing. So even if initially, when you take out some of these kind of more questionable or unethical variables, if there's a dip in performance, it usually makes up for itself within a couple of months. So how do we actually go forward from here, and what do we recommend as next steps? So, first and foremost, it's really important to do an assessment and actually figure out how your brand is using machine learning and AI. Is it being used just for prediction of who's likely to respond? Is it being used for what channels to market to somebody? Is it being used, in a wide variety of different ways that, and then not only that, but are you then handing it off to a third party that is using the models and then potentially using those in a different way? Evaluate if in all of these different ways that you're using AI, if bias is coming in unintentionally, if you're actually looking at the models in the right way and you're doing the right types of validations. And then finally, start to make changes. And I want to be clear, it's not an all or nothing type of thing, right? Like if you just start with evaluating the data, or if you just start with evaluating if there's proxies for, you know, high risk variables, that those are huge steps to be making, right? It's not like you have to be at the end goal. This is constantly going to be evolving. And as we become more proficient in AI and machine learning tools and methodologies, and as we see more and more of it be used in the marketplace, we're going to come up with new solutions and new methodologies and new improvements. But there's always a way to step forward and take action, even if it's not going to be, everything all at once. And I think this last comment here is really cool. It's, that the augmented intelligence, right? There's always going to be that blend of AI and machine learning along with human intelligence that really gives the most superior results. And so, with that, I want to thank everyone for attending the session and sticking with us, and learning about AI and how to do it in the most ethically and unbiased fashion. And I also want to thank Ben a lot for joining me on the session and
Yeah,
giving us all of his infinite industry wisdom. And if you have any questions, please feel free to reach out to us.
thank you.
Thanks.